Looking at number 10, it says we've got an octagon with a radius of length 10. An octagon is not one that works out naturally for me, so I have to do it similar to how I did number 9. I'm going to first start with the total interior angles. So the total interior angles is going to be 180 times times 8 minus 2. Octagon has 8 sides, so it's 180 times 6, and so the total is 180 times 6, which is 1080, which means that each angle is 1080 divided by 8, and 1080 divided by 8 is 135. So each angle is 135. Now, kind of like I did in this problem before, I've got my triangle now, and this angle is half of 135. So before, that angle was half of 108. So now this angle is half of 135, which is 67.5. This is a right angle. It told me the radius was 10, so that's this distance right here. And I'm looking for this one. So now I've got to use a different trigonometric function. It's going to be the cosine adjacent over hypotenuse. So the cosine of 67.5 is adjacent over hypotenuse. So I multiply both sides by 10, and I take the cosine of 67.5. Grab a calculator. So on my calculator, I need to make sure that it's in degrees, which it is. I pressed mode to get that. And so now I'm going to say it was 10 times the cosine of 67.5 is 3.82. The problem said nearest hundredth, so 3.83. So x is 3.83, which means that whole side is 3.83 times 2. 3.83 times 2, 7.66. So the perimeter, I'll write it over here, is going to be 8 sides that are all 7.66 long. So 8 times 7.66 is 61.28. And the area is 1/2 the perimeter times the apothem. Oh man, I don't have the apothem. So I need to find the apothem here. One way to do it would be to find the to use the Pythagorean Theorem. So I've got 100 squared minus 3.83 squared. So I got 10 squared minus 3.83 squared. Take the square root of that. So the apothem is 9.23. 9.23. Sorry. So the apothem is 9.24. I just used Pythagorean theorem right there. And when I multiply all those things together, I get 283.11. A lot going on in that problem.